Hello guys, good afternoon. We will answering our P3 exam. So we will find the emitter voltage, emitter current, the base voltage, collector voltage, overall voltage gain, and we will be assuming that the collector current is equals to emitter current. And also we should determine the output collector voltage. So this is our main circuit. And this two diagram is the DC equivalent and the AC equivalent. So first, before proceeding to our solution, we will be using or applying the Thevenin's theorem or the Kirchhoff's voltage law. So before we can get the emitter voltage, the VE, the VB, the VC, and the overall voltage gain is to get first the Thevenin's resistance and the Thevenin's voltage. So here in the first solution, we will the formula of Thevenin's resistance is R1 times R2 over R1 plus R2. So equals to 47 kilo ohms times 10 kilo ohms over 47 kilo ohms plus 10 kilo ohms is equals to 8.25 kilo ohms. So now we have the value of our Thevenin's resistance. So for Thevenin's voltage, the formula of Thevenin's voltage is R2 over R1 plus R2 times VCC. So the value is 10 kilo ohms over 47 kilo ohms plus 10 kilo ohms times 10 volts is equals to 1.75 volts. So now, our as it stated that IC is equals to IE. So we have the value of IC, which is 1.06 milliampere. So for our emitter voltage, the formula of emitter voltage is IE times RE1 plus RE2 is equals to 1.06 milliampere times 940 ohms is equals to 1 volts. And for our VB, which is the base voltage, the formula of base voltage is to add the emitter voltage and the 0.7 volts, which is 1 volts plus 0.7 volts is equals to 1.7 volts. For our collector voltage, the formula of collector voltage is VCC minus IC plus RC is times RC is equals to 10 volts minus 1.06 milliampere times 4.7 kilo ohms is equals to 5.02 volts. So we have now our value of our emitter voltage, our current, our base voltage, and the collector voltage. So in the next figure, which is the AC analysis, which is we will be getting the total equivalent resistance of our capacitor. So the formula is 25 millivoltage over emitter current. So to substitute, the value is 25 millivoltage over 1.06 milliamperes is equals to 23.6 ohms. So now, we have to determine the base input resistance and the total input resistance, which is our formula of our input resistance is R1 parallel to R2 and also parallel to our base input resistance. And now, for its given value or its formula is to our BAC times um, RE plus RE1 is equals to 175 times 494 ohms. 494 ohms came from for our total of this. And we get the formula because our BAC is in line to our RE1. And our total is 86.5 kilo ohms. And now the attenuation from source to base its formula is V1 over VB. So R1 plus um, um, total input resistance over output resistance is equals to 600 ohms plus 7.53 kilo ohms over 7.53 ohms. And now we have our value of 1.08. And now we need to determine the collector resistance, which is formula is RC times RL over RC plus RL, which is the value is 4.7 kilo ohms times 447 kilo ohms over 4.7 kilo ohms plus 447 kilo ohms, and we have our value of 4.27 kilo ohms. And now we will proceed into the voltage gain from the base to collector, and the formula is is RL over RE1. So 4.27 kilo ohms over 470 ohms is equals to 9.09. And now, so the overall voltage is gained into the reciprocal of the attenuation here, and we just reciprocate it and time and multiply it into our amplifier voltage gain. So the given value is our attenuation is 0.93 times 9.09 is equals to 8.45, and our VC is equals to AV times VC is equals to 8.45 times 10 millivolts. And our final answer is 84.5 millivolts. And that's how we get our assessments or the given questions. Thank you.